Alright, welcome back. So, why are algebraic equations interesting? Why are they useful? Why do we care about this? And the answer is that when we have an equation with more than one variable in it, sometimes that equation is designed to capture some relationship between things in the real world. So I'll give you an example. Imagine you're driving in a car and you're driving at 60 miles per hour. You can substitute kilometers if you prefer, but you're driving at 60 miles an hour. And suppose you drive for 1 hour. How far are you going to travel? Well, 60 miles per hour means in 1 hour you drive 60 miles. So this is going to be 60 miles. If you drive 2 hours, well, in the first hour you're going to drive 60 miles. In the second hour you're going to drive another 60 miles. You're going to drive 120 miles. But more particularly, you're going to drive 60 times 2 miles, which is 120. And if you were to drive for 3 hours, how far are you going to go? Well, you're going to go 60 miles in the first hour, and then the second hour you'll go another 60, and the third hour you'll go another 60. In other words, you're going to travel 60 plus 60 plus 60, which, as we saw, we can write as 60 times 3, which is 180 miles. So we can write an equation. If you're traveling at 60 miles an hour, and if you travel for a time t hours, then your total distance d is just 60 times t, where this is miles. And so we're writing another algebraic equation, but this particular equation describes something in the real world. It says if I'm traveling at 60 miles an hour and I travel this many hours, t, then I travel this much distance, 60 times t. And we can test that that works in a few cases. For example, if I travel 1 hour, t is 1, 60 times 1 is 60, I should travel 60 miles. Well, that's what I do. If I travel 3 hours, t is a 3, 60 times 3 is 180. This formula says my distance should be 180 miles. Well, that's what we calculated it to be. So this is an algebraic equation which tells us if you travel for a time t, your total distance will be 60 times t. Alright, so that's another algebraic equation. It involves two variables, just like our previous one, x plus y equals y plus x. But this is a really useful equation. We can use this to answer a couple of different questions. One question is, if I travel for this much time, how far do I go? Well, I travel 60 times t. But there's another question which is not as easy to answer, which is the following. How long will it take to travel 300 miles? Now this equation says if I know how long I'm traveling, this is how far I travel. But I'm asking a different question now. I'm saying if I want to travel a total distance of 300, how long do I have to travel? And this is classic algebra now. We have an equation which relates time to distance. And if I know what my time is, I can plug in that value for t, and this equation tells me what the value of distance is. But I have a different problem now. I want to travel a distance of 300 miles, and I want to know how long that takes. So we would say I am trying to solve an equation 300 equals 60 times t to find the value of t. In other words, if t is 1, I get a distance of 60. If t is 2, I get a distance of 120. What's the value of t that gives me a distance of 300? That's the question, right? What's the value of t, the time it will take to travel a distance of 300? So I can use the same formula, and I can plug in, instead of the number of hours, t, I can plug in the number of miles, d, 300. And whatever t is, 60 times t is still going to equal 300. So now I have an equation like this, and this is the famous thing you bump into in algebra where it says, find t. This is the first instance where we're being asked to solve an equation to find the value of a variable. When we have an equation like this, we can plug in the value of a variable and find, what the other side of the equation is equal to. But here, we're trying to find the value of t, which makes this equal to that. And so this gets into algebraic manipulation. How are we going to find the value of t? Well, we could do it by trial and error. We could try t equals 1, 2, 3, 4, 5, 6, 7, 8, and try to narrow it down and find the exact value of t. But there's a different way, which is to manipulate this equation so that we can find what t is actually equal to. Well, this equation in particular we could manipulate by dividing both sides by 60. Okay, now this is a weird thing to do, but if this is equal to that, I can multiply this by 2 and multiply that by 2. They should still be equal. Similarly, I can divide this by 2 and divide that by 2, and they should still be equal. And in fact, I can multiply or divide by just about anything. And if this is equal to that, dividing both sides by the same thing makes them still equal. So I'm going to do the following. I'm going to say 300 equals 60t. 300 divided by 60 equals 60t divided by 60. And this left side, 300 divided by 60, well, I can just calculate that, but to be 5, I can divide it or put it on a calculator. 60t divided by 60. Well, if you think about this, I'm taking t, multiplying by 60, and dividing by 60. That's just going to give me t. So I can solve this equation and end up with t equals 5. That's my answer, 5 hours. Okay, again, that worked in a specific case. I knew my distance was 300, and I knew that I was traveling at 60 miles an hour, and I wanted to find the time. Well, I could divide by 60 because I knew ahead of time, because I've done this, that if I divided this side by 60, I would end up with just t. But what does this look like in general? If I don't know that my distance is 300, maybe my distance is 420, well, I could do this again. I could put a 420 equals 60t. I could divide both sides by 60. I would find that t is equal to 7. But algebra, we're trying to abstract. We're trying to find a general situation. And here's what that looks like. If d is equal to 60 times t, I'm just going to go ahead and divide both sides by 60, and I'm going to say d over 60 equals 60t over 60. We'll take t, multiply by 60, and divide by 60. That's just going to be t. So I've got a new formula, and I'm going to switch these around just to make it look a little more like what we're thinking of. And I get this formula, t equals d over 60. And this is a second formula that lets me, instead of plugging in a time and find a distance, lets me plug in a distance and find a time. So now if you say, okay, how much time does it take to travel a distance of 300? It's just 300 divided by 60, 5 hours. How long does it take to travel 600 miles? 600 divided by 60, 10 hours. So with this original equation, this d equals 60t, we've been able to come up with a second equation, which is t equals distance divided by 60. Now we're doing algebra. right? We're taking an equation and we're manipulating it in particular so that this first equation, where we plug in t and we find d, we turn that into a new equation where we plug in distance and we find time. And going from here to here, that's an example of algebraic manipulation, or what we might call solving this equation for t, trying to find an equation that follows from this that tells us what t is equal to. All right, and let me take this one step further. All of this was premised on the idea of going 60 miles an hour. What if we're going 50 miles an hour or 75 miles an hour? Do we have to redo all of this work each time we have a different speed? Well, we could, right? We could plug a 50 into here and 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 so on. And then if we were doing 75 miles an hour, we could plug a 75 in here, 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 and so on. And if we do that, we're going to get a more complex equation. We're going to get an equation which says the following. If your speed is s and your time is t and your distance is d, we're going to find the formula d equals s times t. Your speed times your time tells you how far you go. And that, is exactly like this, where our speed was 60, we got d equals 60 times t. If our speed was 50, we would find d equals 50 times t. And just like we got a formula over here by dividing both sides by 60, we can now say d divided by s equals s times t divided by s. And t times s divided by s is just t. And so we can get another formula, t equals d over s. So if we know that we want to travel 400 miles, and we're going to travel at 50 miles per hour, this formula says d is equal to 400 divided by 50. That's 8 hours. So if we want to travel 400 miles and we're going to travel at 50 miles an hour, this formula tells us it's going to take us 8 hours. We're doing algebra, right? We've got 3 variables here, and they're all coming from this very basic relationship, distance equals speed times time, which is a general version of this formula, distance equals 60 times time, which is really just a version of, traveling 60 miles an hour for 3 hours is just going 60 miles plus 60 miles plus 60 miles, which is 60 times 3. So we've got one equation, we've got a second equation, and we could turn this into a third equation. Instead of dividing by s, we could divide by t. And we could say d equals s times t, d divided by t equals s times t divided by t. Well, s times t divided by t, that's just s. And so we've got a new formula, s equals d divided by t. And what does this formula tell us? If you want to travel this distance, and you want to drive for that much time, this is the speed you need to travel. So if I want to go 100 miles and I want to do that in 2 hours, my speed has got to be 100 divided by 2, that's 50 miles an hour. So all 3 of these equations are basically the same information, but algebra lets us manipulate them into different forms. In this case, I know my speed and time, and I want to find distance. In this case, I know my distance and my speed, and I want to find time. In this case, I know my distance and time, and I want to find speed. So this is a big leap from our previous video, but this is the essence of algebra, right? This is the fundamental idea of expressing a relationship between things in the real world using an equation, and then manipulating that equation to find the values of some pieces based on the values of other pieces. So play around with this, go back over the examples, come up with your own examples, mess around with it, and over time this will start to make more sense. And once we are comfortable with, going from here to here to here and so on, then we can start abstracting this process even more and start thinking about equations in general. And that's when we start getting into the deeper aspects of algebra and some of the properties of these algebraic equations, and then we can start using these for all kinds of things. All right, thanks.